thrust force and any frictional interaction in the pin. Remember that? However, if it's not as complex as the beam, for instance, if it's a bridge or something, you could, or a seesaw type of arrangement, or obviously there's maybe not a hinge present. The hinge always is going to be the pivot point, because that's the point about which, like a piano hinge, where it's going to be rotating. So that sort of dictates the position of your pivot point. Yeah, Sierra, it's the end, but it's the leftmost end. It's usually by convention. Although, I'm not going to tell you, use a conventional pivot point, because you can actually put it just about anywhere that would yield fewer torques. Now, I know a lot of you who plan to go into engineering will probably be taking either a circuits class after your physics 2 or a statics class. And I tell you, I hope whatever professor you have at whatever university you're at, I hope that you know that this professor told you to indicate your pivot point. Don't ever say you were never taught. I mean, it's hard enough already online, but this is the one concept that I hope you got from Chapter 12. Because if you don't show your pivot point when you get in your statics class, they're not even going to grade your homework problem. Probably not grade your homework assignment. They'll give it. In fact, they won't give you a resubmit. They'll tell you that you need to go back and maybe retake physics 1 with calculus. That's how important that pivot point is, ladies and gentlemen. And after you turn in your test Thursday, and I get to those torque problems, and if I don't see a diagram, even if one is furnished, if I don't see a torquing diagram, or if I don't see a pivot point, I'm not going to grade it. It's a 0. Because you're just saying, well, you know what a pivot point is. It's sort of implied, but show me. That's the requirement. Show me where that pivot point is. Now, once you write your torque equation, and I think you found from your homework that we restricted, did anybody notice about how many torques were involved in the examples that I gave you, and the ladder, the beam, and the football bench, which is like the seesaw homework problems and stuff, or the PowerPoint presentations? I tried to confine it to not more than 3 torques. However, we know that you've got to have at least 2 torques if you're in statics, which means 1 clockwise and 1 counterclockwise. You may even want to label, once you have distinguished the pivot point, which of the torques are clockwise and which are not, which are counterclockwise. So if you miss the problem, I can at least give you partial credit for identifying what you need to know, ladies and gentlemen, before you even start filling in your equation. And everybody should have a variable equation. Fill it in with the numbers, and then justify your answer. Torque problems are easy to justify. Every term is a Newton times a meter. They're not that hard. I have found some of you have not indicated when you use the sign of the angle. You don't tell me if you're using degrees or radians. Ladies and gentlemen, we had a problem on dot product where you had to extract an angle, and a lot of you, because you had not designated a degree or angle, had your calculator in radians and gave me an answer that I knew were the radian, because I converted both so I could recognize the answer. On a multiple choice test, obviously all the answers will be in degrees. If not, the radian will be in the multiple choice answers. The reason why I really talk about units in homework is because in a multiple choice test, usually the units are given, which means you're not trying to justify units on multiple choice tests. Now, on your final exam, it's free response. You've got to justify units. So the way I'm trying to get across to you that units are extremely important. Some of them are easy. Like if you're doing torques, you know the answer is going to be in a Newton times a meter. Every term then has got to be a Newton times a meter. That's not too hard to label your units. Extremely important. And always check your answer. I got some answers in Chapter 12 that were based on erroneous equations, and you did not go back and check the solutions to know that you're absolutely wrong. Part of what you'll be doing in upper division is you'll be given answers because they are so complex. A lot of upper division problems in science take a whole page to do and are multiple steps. And if you don't know where you're going, an answer, you're not going to know if some of those steps are going to lead you to the wrong answer. So a lot of professors will give you the answer, or there's a study guide or something to give you some idea how the answer should go. Any questions so far, ladies and gentlemen, on these 16 points and a discussion of Chapter 12? I don't know if any of you remember what you did in Chapter 12, but some of you may want to resubmit the solutions to some of those problems. And while you're doing you're resubmitting solutions that contain diagrams and pivot points, you will be practicing for your test on Thursday. And I don't mind accepting a redo when, at this level, it's learning the methods of science. Not what I want, it's what I've got to tell you that's needed, ladies and gentlemen. That's why I will not do web assistance homework. I do my own grading. I learn more about what I have to say to you. Web assist is going to say, try again, or this is what we think you did wrong, and then not really show you how to do it right. They haven't got that far yet in their feedback. Okay, ladies and gentlemen, no questions so far. Have you got a pencil and paper? Make sure you have a pencil and paper, ladies and gentlemen. Pencil and paper. I give you about a minute to make sure you got pencil and paper. Oops. Okay, nobody said no, so I'm going to assume that you need a few minutes here. Okay. Actually, I'm going to try to put this on the whiteboard too. Got it. I like it. Thank you. I sometimes wonder if next slide. Okay, next. Okay. Let me get this active again. Okay, there we go. Woo! Okay, come on. Oh, I know why it won't go to the next slide, because this is a file. So all right, I'm kind of stuck here a little bit because I want to keep this on the screen. Ready? Okay, ready, set, go. Thank you, ladies. Chapter 12, and the reason why there aren't more problems is they take more time. And this, of course, is test 4. Oops, test 4. There you go. And there you go. Chapter 12 has 4 problems. Now, all of the problems on this test are worth 5 points, because I got to start averaging grades for a grade determination. And that can mean that they're 5 points each, that the hard problems and the easy problems are all worth the same number of points. And in the quiz today, you know, there was hard problems or questions, and there is a question on the exam that's very similar to one of our quizzes. There are 4 problems, obviously valued at 5 points, which is 20 points. They all involve torque. They all involve a pivot point. If you work these 4 problems without indicating a pivot point, you lose how many points on test 4, ladies and gentlemen? The answer might be right. 20 points. Thank you, Henry. Ladies and gentlemen, you don't want that to happen. And I had this test made out long before we got to chapter 12. In fact, these are in my test bank. So I'm not picking on you folks. This is the same 4 problems that they had last semester and the semester before. I just changed the numbers, or it came out of a test bank of about 12 identical problems, and I just pick and choose from them. The bench type, the beam type, the ladder part, and then balancing, say, a meter stick or something. Oops, I just gave away the 4 types. If there's a diagram, be careful using the diagram. Your pivot point may not be along a point where it would rotate. If you use a pivot point supporting the center of mass, you're going to have 2 unknowns. Because the center of mass, we know, is acting vertically down. Be careful. My suggestion was, where is, by custom, the pivot point? Now, I'm not claiming all 4 is going to be in this orientation, but the first place you should look is where, folks? Uh-oh, did I lose everybody? No, I'm not mad. I'm just trying to make the point. I'm trying to, what is it, boldface or something. Left side, thank you. We got it. I hope everybody's paying attention. Okay, chapter 12, 4 problems. Chapter 14 is where the emphasis is on this test, because it really gets to a state of matter which we've studied solids up through chapter 12 and 13, which was on a previous test. 14 involves fluids, and by fluids we mean anything that flows, which is your liquids and gases, and for that matter plasmas, but that's way, way, way high temperature, way out of our preview of study. There are 9 problems. Oops, okay, I'm running out of room here, and I don't think I can move it up. So 9 problems. Actually, there are 8 problems and 1 question. So the 1 question, I'm going to put parentheses here. Little question. All of them worth 5 points. Some of them, admittedly, are more important than others. But the defining fact is sometimes you need to know a quick one to be able to do a more complex. Now, ladies and gentlemen, one of these problems revolves around buoyancy, obviously. And there are multiple possible answers depending on whether or not you do it right or not. But I will take your answer, whether or not it's right or wrong, and I have a second question about the same situation. And if you get the answer correct based on your wrong answer for the second problem, you will receive full credit. And the reason is I want some continuity of thinking. And I just don't believe in part A and B of problems. So both of them, one of them is a little easier than others. But there is a situation with buoyancy, and I have pictures. So look for the picture problem and spend a little more time on it. After all, you have the whole class period for test 4. In fact, you may want to come back to it. But if you get it wrong, and you use that wrong answer, and you get an answer to the second problem based on your wrong answer, I will accept it because I know the procedure I'm looking for. In other words, they call that follow-through with respect to your thinking. Now, that should leave about 7 problems, and I'm going to go way over here. And chapter 15. The reason why it's really worth 7 is, remember, it uses, we went back from chapters 7 and 8 and involved energy considerations. Energy, I'm pretty sure a lot of you have concluded by now, is a better way of solving all problems in physics. Where does the energy go? How is it then utilized? Because it does not depend on whether or not the acceleration of the system is constant. So conservation of energy law is by far the more fundamental. There's no such thing as conservation of force. Excuse me. Is the reason why I went back into some of the energy discussions. Please know or note, and this is in chapter 15, but they kind of assumed you already got it from chapter 7. Understand that the energy stored in a spring, once it's been pulled down or compressed with an external force that's now out of the system is conserved. We knew that from chapter 8. We applied that in homework and tests. But know the equation for that energy is 1/2 K x squared. And the x is squared, so the spring does not see energy in compression any different than energy in elongation, because it's seeking the center or rest position of that spring. In fact, it's related a little bit to the elasticity lab, which I'm currently grading. I'll try to get it graded so that you can see it before this particular test. And a lot of you realize that you can pull it to an elongation, and you got a graph for it, and you kind of hold it there. From what I see, you did it very good. Some of you even did a screenshot of the graph. That was not required, but it was nice, ladies and gentlemen. Any question now about, whoops, I don't write chapter 15, and there was, let me bring it over here, there were seven problems. They're all problems, ladies and gentlemen, related to very closely your homework. And if you want to add the problem that you did, I believe it was in chapter 7 or 8, I think it was problem 13. If you want to do A and B and C, and I think there was a D, feel free to do so at this time if you want a few optional homework points. Not required, not extra credit. If you elect the option, that would be fine. Okay. I, of course, will be in conference. I usually open the conferences about a quarter till class, 12:45. If you have any burning questions you would like to ask, don't type them. I'll answer it verbally, unless I want everybody to see the answer to your particular question. Then, let's see. Okay, got everything I have on my notes. Then, let's talk a little bit about the final exam. We know, of course, that it's going to be 10 free response. There will be a solution key to all quizzes, which I hope to have to you by Thursday, so that if you want to look over it after you have submitted your test. I'm going to stay live in conference until 5 o'clock. Feel free to come back in conference and make a comment about the quiz answer keys. That would be fine. The final exam, as I mentioned, will run for 45 minutes. So you may want to get a copy, especially if when you transmit the final exam, if it's done very quickly, you can transmit it a little bit later than the 45 minutes and still get it in. Ladies and gentlemen, transmission has been very, very erratic. I realize that from other students feeding back information from other classes. Not quite sure, other than everybody's doing finals this week. However, most people are not using next Tuesday. They're finalizing all of their grades this week. Science, anybody taking a science class probably will be doing a final exam next week. And I think that transmission for this final exam is going to be more efficient because everybody else has tested this week. In fact, we did too on Thursday to finish out our chapter exams. In fact, one of the replies when a bunch of us that meet when we're teaching online is everybody that was non-science are going to be finished with their testing in this particular chat room, and only 3 of us in science a physical science, astronomy, and a biology and a chemistry and a physics person. That's me. So it looks like it would transmit more easily, I'm hoping. If for some reason you're transmitting right at the, say, 2 o'clock time and it looks like it's not taking, please send me an email saying, Ms. Dewberry, I am desperately trying, and then maybe call me or come into conference and tell me that you're having trouble, okay? Or call my phone and leave me a text message or a voice message so I can record the actual time, ladies and gentlemen. Time is, of course, of the essence. Again, during the final exam, I will be on conference. In fact, I'm paid to be on conference the entire class time. So after I get all of the final exams, I'm going to hold an open conference and start grading the final exams. I won't guarantee I grade them all by the end of your class time, but I should have, I'll grade all of number 1 and all of number 2. I don't grade individual tests. I get a copy of your answer key or your solution key. In the case of a final exam, your handwritten. I will know then, because I'll have class time, I will know whether or not I have received your final exam and can send you an email saying, I have not received it yet. Please submit it ASAP, which kind of tells you that I didn't get it. So if I'll have about 2.5 hours after your final exam to spend time in conference sorting things out for us. Okay, so what date can we expect all of the grades to be inputted for this class with the exception of the final and lab 7? This way we can transmit the assignments if needed. My hope is by your test 4, and it looks like it will happen. So I did slow down in chapter 12, unfortunately, and I'll, of course, have your conference time today, maybe to finish up chapter 12, go on to 14 and 15, and then I'll backtrack to chapters 10 and 11. All day tomorrow I'm grading, all day Thursday while you're taking the test I'll be grading. Usually that much time for both classes is what I need to do about a week's worth of grading, and that's what I have left approximately. Is that better, Henry? Yeah, and everybody heard me?
So so like for example, lab 5, which was the elastic lab, and lab 4, circular forces, will be graded and whatnot by then?
Yes. In fact, I think the circular force is graded. I just need to record them. What I do is I print out all the labs, ladies and gentlemen, and I sort them by their lab, because some of you submit more than one at a time, and there have been two due at one time. And then I have to see a data table with your conclusion. I have to see those 2 pages together to see if your conclusions really are valid with respect to the variables that you changed. And ladies and gentlemen, you do excellent with that. You notice I have never complained about the structure of the labs that I'm grading. In fact, I encourage you to use your initiative. That's something that's much needed by engineers and computer programmers. You've got to take your initiative. When you're given an assignment, you're not given how to do it. You're just saying, we need to write a program for managing someone's finances, and they've got 15 investments, and they want this to be the limit to what they can maintain, and they want to sell the stock if it gets below so-and-so, and it doesn't tell you how to write that program. In the case of building a bridge, the architect will have a design, and he'll expect then the engineers to say, how can we build it to that design? Sometimes they have to modify the design. Architects are not necessarily engineers. And so taking an initiative is, even in a face-to-face lab, in upper division, when I was at Florida, I know it was a long time ago, but they do about the same thing, and they're using the same type of book for information for labs. They do not have the lab written out. They said, we're going to be, I'll see if I can think of an example when I took analytical mechanics. It involved what they call a rotational tangent galvanometer, which included an electric meter type design, but what you wanted to do was swing it back and forth to indicate what kind of current you had, which is torquing effect, folks, and the principle behind meters, actually. They didn't tell you how to do it. Usually you work with one other person. Some universities have 3, and you work it out. And your particular lab may not be like anyone else's as long as it works. Same thing for a senior, especially in engineering and the computer programmers. You work on a project as a senior, and at the end of your senior year, you present it. Many years I went down to Florida because I had students that were presenting their senior exercise or whatever they were building or something. And you have to present it to invited guests. And I was always amazed at how some of my students had finally learned how to take the initiative and look at what each one of the people in their group. Florida likes to use groups of 3. Odd numbers then are easy to overcome where you got 2 arguing with one another, so they used odd numbers. That was what I thought would be developed in virtual labs. And in last semester, I found that to be true because the kind of labs that I picked to a lesser or greater degree. And I have been impressed by, particularly when you have constructed your own data tables, ladies and gentlemen, and picked the variables you wanted to include. And then when you started writing your conclusion, I could see where no wonder you concluded those facts, because it is evident from your data table. That's why when I knew that I was delaying the grade of labs, I knew almost everybody's going to end up with, I would hope that all of your labs would come out to an average of about 8. So I wasn't too concerned about labs. You have hit the mark as far as I'm concerned with respect to taking initiative, and that was one of the objectives that I learned to try to encourage last semester when we went totally to virtual. And of course, most of my students had already had 5 face-to-face labs, so I knew them, and then they could tell me that they had to take an initiative when they do that Newton's Law lab that you did in virtual. I got a lot of feedback from the class in the spring semester, and it worked. It worked for what I was looking for. Outstanding, ladies and gentlemen. I could have known that, because you would not have gotten this far if you were unable to master things in, look at how analytical calculus is at the level you're taking. And it just gets more so as you get into calculus 3 and differential equations. Okay. Oh, yes. Oh, thank you, Henry. Gotcha. Don't mean to go out on a tangent, but I still am going to leave you. Most labs can be done, you probably discovered, in about 2 hours, and it takes maybe about that long to present it in the data and sample calculations that establishes your values in your data table, and then your conclusions. I didn't mean to be so long-winded, but this is about the last time I have time to talk to you at length about the success as a class that I think that we have achieved. And it's come out of letting you think for yourself and apply some initiative, which, ladies and gentlemen, I think you're ready for upper division and the challenge of whatever field of study you have, to be frank with you, as long as you stayed with me. And I've got 2 people that have never joined the conference this evening, which is rare, but I have been printing out who's in attendance for the last, I guess, something like 6 weeks, and I think it may be a consequence of their grades, because everybody that's online continue to turn in work, and which I appreciate, ladies and gentlemen. At this time, if you would like, I'll dismiss you to your virtual lab. If you've already done it, but would like to redo any lab at this time. Don't turn in lab 1, 2, or 3 because I already doubled the Newton's Law lab for the first lab. But if you missed the second lab and would really like to do it, feel free to. Then turn it in with your 7th lab. If you want to go to the Momentum lab, but that is, I believe, Boston University, and they changed that lab. Now they just have the values for velocity instead of allowing the photogate timers to measure the average velocity like the technique in the first lab you did. There's also an impulse lab that some of you may have looked at. Feel free to submit it if you'd like, but it's not required. Okay. Can I just say you're dismissed? Anybody got any more questions? And I'll sit here with open conference grading, finishing up chapter 12, okay? Say have a lovely, yes, John. All right, that's Pascal's principle. What he wants you to do is change the cross-sectional area of one piston and see what happens. I think you can change it to the left and then get data and then change it to the right. Just change one. That kind of proves the point. And then the second thing is keep the piston's cross-sectional area the same, but vary the force you put on one piston and see the effect on the second. That's what he's after. Because once the design settles, it's really saying that the pressure along one cylinder is exactly equal to the pressure on the other cylinder. You have to kind of read what he's got there, but our discussion of Pascal's principle, you know that once it settles, that the pressure in one tube has got to equal the pressure in the other, okay? And I mentioned 2 variables you want to change independent of one another, the cross-sectional area, and then do experiment. And then keep the tubes, you can even keep them at the same diameter if you want to, and then add more mass or weight to one piston and see what happens to the other. And if you put too high a weight, it will tell you that it's out of the range. In other words, the fluid in the other piston would just fly up and overflow. So they'll limit it for you. Okay? Does that help, John? Yes. If you're doing, yeah. Well, convert the grams to kilograms. And then if you want to convert the kilogram to a Newton, because you're dealing with weight, multiply by 9.8 meters per second squared. However, before you do that, if you're taking a ratio between the weights in both, pressing down on the piston of both cylinders, when you take a ratio, that acceleration due to gravity cancels out. So you may use then the ratio of one mass over the other. You see why they didn't give you the value then? Yes, that's good observation. See, that's attention to detail, John. And I find everybody's doing that. I don't know if you've been doing it all along or if my persistence in talking about limitations and observations, I'll never know, but I don't care. As long as you get to that point, we have been successful. Okay? Yes, good. All righty. I'll see everybody. I'll be on conference. Actually, I'll be grading papers while I'm live. I still have everybody. I said I was going to go over the answers to quiz 19, so let me do that. 5 points. Give the continuity equation. The other thing about continuity equation is the flow rate. And remember, I mentioned gallons per minute. Well, the flow rate is a volume, usually in meters cubed, could be in liters, and the time is always seconds. So you're looking for meters cubed over seconds. Then the equation is capital A sub 1, little v sub 1, which is the area, and v is the velocity of the tube of flow that has a given volume, equals A, capital A sub 2, little v sub 2. In fact, going back in your notes, in Chapter 14, you'll find a continuity equation is introduced before they even get to Bernoulli's principle, because you need to know the flow rate of the fluid. In the case of the airplane, it was air. In the case of a hypodermic needle, it'll be whatever's in the needle type thing. The design should look something like a funnel with a long neck, and it goes from a very large cross-sectional area of a given volume to a very narrow bottleneck with the same volume. Remember, we were tracking volumes of flow. This is upon which conservation law is Bernoulli's principle based. Ladies and gentlemen, that's got to be the conservation of energy principle. What did I just draw a circle around? Chapter 15 and fluids, because the acceleration is not uniform, has got to use conservation of energy. I don't know if any of you plan to go into fluid mechanics. I have a student in the other class that's looking at propulsions of various kinds, not necessarily rockets. And she's going to be dealing with propulsion fluids or liquids at their flow rate to see what the thrust will be. Very complex. Okay. Why can airplanes fly? Well, as air goes over the top of the fuselage and wings, the airflow speeds up to maintain approximately streamlined conditions, which means every point on the streamline tries to stay along its perpendicular line referenced in the streamline. But it's only an approximation. It depends on, let's say we have no wind blowing and it's calm, so that would be more applicable to streamlines. Thus, the velocity at the top of the fuselage and the wings, and that plane surface there, increases. While Bernoulli's principle tells you that if the velocity of the fluid goes up, the pressure goes down. And if you've got a lot of surface, remember force is equal to the perpendicular force applied to a given area, as if it were, the area has to be a rigid body, though. I think the book mentions that once. This decreased pressure will provide a decreased force along the top of the fuselage and plane wings. And that decreased force means that the air below the plane is going to be pushing up, and you get then a lift force, because it's trying to increase the pressure on the top. Pressure on the bottom is greater than the pressure on the top. You get a lift trying to equalize the pressures. And it's a tremendous lift because of the compression of the air. Any questions at all about those three answers, ladies and gentlemen? I hope you made a 10. There's about 5 of you that needs less than 5 points to get your 50 points. And then close to 90% of the class will have their 50 quiz points out of 105, ladies and gentlemen, which means you could get half of every quiz wrong. I hate half of every quiz right, and you would get the maximum, which means I tried to encourage you to continue to answer as you see fit. In the limited time you have to study from one quiz to the other. Okay, I still got the same number of students. So I'm going to officially now dismiss everybody to lab. Is that okay? But I'll be here. I'll just be grading papers. Oh, thank you, everybody. It's been a pleasure having you this summer. Kept me busy, obviously. Okay. So long, everybody. You can stay connected to conference. You don't have to go off.